In this section, we'll be looking at fork join framework. With the advancement in the hardware, where even mobile phones have multiple cores, the programming paradigm requires effective use of multiple CPUs/cores. The effective use of parallel cores in Java application has always been a challenge. Java 7 has therefore implemented a fork and join framework that would distribute the work across multiple cores, then join them to return the result set. Fork join breaks the task at hand into multiple tasks until the mini task is simple enough that it can be solved without further breakups. Fork join is like divide and conquer algorithm. The fork join framework is distinct because it uses a work stealing algorithm. Worker threads that run out of things to do can steal tasks from other threads that are still busy. Fork join framework is based on Doug Lee's work on Java concurrency, and it employs the following pseudocode. It states that if problem is small, directly solve problem, else split problem into independent parts, fork new subtasks to solve each part, join all subtasks, compose results from subresults. Fork join splits the main task into subtasks. So the first task is split into, in this example, is split into two tasks, and then the subtask is further split into multiple tasks. And the join the results of subtask into the main task. So all the results are basically joined into the main result. Fork, a task that uses fork and split itself into smaller subtasks. Join, a task that joins all the results into one result. Fork join pool. Fork join pool is a specialized implementation of executor service implementation with the work stealing algorithm. If you recall, we submit multiple independent calls to executor service, which are then executed by the thread pool threads. To execute a big task, we have to perform the following action. Split the task into small subtasks, process subtasks independently, join the subtask results into a final results. Fork join internally does all the above steps for us. We just submit task to the fork join pool, and fork join pool will work to divide and conquer the problem and return the results. Fork join pool creation. We create a fork join pool using its constructor. The constructor takes the level of parallelism you desire. Parallelism dictates the number of threads or CPU you want to concurrently work on the task. Submitting tasks to the fork join pool. You can submit two types of tasks to the fork join pool, recursive action and recursive task. The only difference between these two classes is that the recursive action does not return a value, while recursive task does have a return value and returns an object of specified type. With this, it's the end of this section where we look at the fork join theory and fork join pool theory, and in the next section we'll be looking at the implementation of fork join. So I look forward to see you in the next section. Thank you for joining me in this section.